This video takes you through the Real-Time Edge Intelligence Solutions Handbook, commonly referred to as the RTEI Handbook, showing how it brings together DSP algorithms, AI, embedded processor technology, and vendor toolchains for building real-world edge AI systems suitable for commercial deployment. What sets the book apart is that it combines concepts, implementation, system design, new product development, and standards-driven engineering within one coherent framework for real-world use. The content is reinforced by insights from recognized industry experts with extensive experience in designing algorithms for commercial deployment on ARM Cortex processors, together with perspectives shaped by ARM architecture teams, semiconductor companies, and engineering tool specialists. The result is a state-of-the-art solutions handbook that not only explains the principles, but shows how they can be applied to build reliable, real-world edge systems. The book is organized into three main parts, structured across the following four key sections: context and foundations, signals and systems, implementation and hardware, and real-world use cases. Many books teach the theory. This book shows you how to make it work on edge hardware. We begin with context and foundations. This section defines the key concepts, what we mean by AI, machine learning, digital signal processing, human intelligence, and digital intelligence in the context of real-time edge systems. It explores the strengths and limitations of each approach, and why no single method is sufficient on its own. It also discusses how digital intelligence can augment human intelligence, together with concepts such as feature engineering and the role of domain knowledge in building useful systems. An interesting historical overview also shows how embedded processor technology and tools have evolved over the last 50 years, helping the reader to understand how the field has developed, and how we've arrived at where we are today. More importantly, this first part contains no mathematics, and is deliberately built around concepts and examples, so that the reader can clearly understand how these ideas fit together, where they're applied, and why they matter before moving into the more mathematical material discussed next. At the core of the book lies signals and systems. There are already many books that do a very good job of teaching the theory. But in truth, you go through the mathematics, you understand the concepts in order to pass the exam, and then you're left asking, so what now? How do I actually use this for my projects? That is precisely the gap this book addresses. In many ways, where university textbooks finish, this book takes off. As you can see, the book provides a comprehensive overview of modern signal processing techniques. It takes the reader through the core methods engineers use every day, including the various flavors of the Fourier transform and their properties, such as integration and differentiation, with practical examples showing how these ideas are used in real systems. It also introduces more specialized topics that are rarely discussed, including the chirp Z transform, which allows you to zoom into a frequency region of interest with very high resolution. From there, the book moves on to IIR and FIR digital filter design, providing developers with practical design advice on which prototype to use for their application. What makes the material especially useful is that it's supported by loads of hints and tips, real-world examples and datasets, helping you to bridge the gap between theory and practical implementation. It then moves on to introduce more advanced topics such as Kalman filters, starting off with a formal definition of the framework and practical example, before moving on to the modeling of nonlinear systems and comparisons between Kalman filtering and data-driven AI methods, and practical advice on building complete tracking systems. The book moves into implementing RTEI systems on edge hardware. This is where algorithms are translated into efficient embedded solutions, taking into account analog front ends, practical issues with analog to digital converters, data types, and efficient implementation on edge hardware. This part also describes the steps and workflows needed for building commercial systems that align with the customer and stakeholder requirements via the new product development process. Finally, detailed use cases show how these ideas come together in real-world edge applications, from biomedical sensing to industrial systems. These examples demonstrate how the theory, the implementation, and the system-level thinking all connect in practice. The perspective is grounded in practical experience, supported by input from recognized industry experts, who have designed the processor technology, developed libraries, and implemented these solutions in commercial applications. So, if you're looking for a detailed and practical reference for implementing edge AI and next-generation edge intelligence solutions, this is the book for you. Further details are available in the description box. So go ahead and order your copy, so that you can start your journey into building RTEI solutions that deliver real impact and meet your customer expectations.